is anything that has mass and can take up space. Everything on Earth consists of matter and can be found in items we use every day, such as plates and water. There are two different types of matter, pure substances and mixtures. A pure substance is matter that has definite composition. Elements and compounds are two different types of pure substances. An element is the simplest type of a pure substance. A compound consists of two or more different substances that combine physically. We interact with mixtures on a daily basis through the air we breathe, which is a mixture of oxygen and nitrogen. There are two types of mixtures, heterogeneous and homogeneous. A homogeneous mixture, also known as a solution, has a uniform composition, while a heterogeneous mixture does not have a uniform composition. A solution of salt and water is an example of a homogeneous mixture, while soda is an example of a heterogeneous mixture. Here we have a visual. It reads, identify each of the following as an element, a compound, or a mixture. A is a compound because the molecules have a definite ratio of 2 to 1 of atoms. B is a mixture because it has two different kinds of atoms and molecules, while C is an element because it has one kind of atom. Here we have the website. It's the concept of classification of matter in this interactive game. Before starting each level, you must correctly answer a question involving matter. If you answer correctly, you must then drive a taxi to the next level in a certain amount of time. Here we have a question. It reads, clarify each of the following as a pure substance or a mixture. A is a soft drink, which is a mixture. B is propane, a pure substance. C is a cheese sandwich, a mixture. D is an iron nail, a pure substance. And E is a salt substitute, which is a pure substance. At the bottom, we have a multiple choice question. It reads, the water we drink, H2O, consists of 2 atoms of hydrogen and 1 of oxygen. What is the bond between these atoms called? This bond is known as C, a compound. For 3.2, I had states and properties of matter. On Earth, matter has 3 physical forms called liquids, solids, and gases. A solid has a definite shape and volume. A liquid has a definite volume, but not a definite shape. And a gas does not have a definite volume or shape. Physical properties are characteristics that can be observed without affecting the identity of a substance. These include color, shape, boiling point, and physical state. A physical change occurs when the state, size, or appearance of matter changes, but its composition stays the same. Examples include cutting paper or boiling water. Chemical properties describe the ability of a substance to change into a new substance. This includes a piece of paper burning, a piece of wood burning, or rust.
Temperature in science is measured and reported in degrees Celsius. In the United States, everyday temperatures are commonly reported in Fahrenheit. A typical room temperature of 22 degrees Celsius is the same as 72 degrees Fahrenheit. The temperature difference between freezing and boiling is divided into smaller units called degrees on the Celsius and Fahrenheit scale. On the Celsius scale, there are 100 degrees between the freezing and boiling point of water, whereas Fahrenheit is 180 degrees between, meaning that degrees Celsius is almost twice the size of a degree Fahrenheit. 1 Celsius equals 1.8 Fahrenheit. We can also write an equation that relates Celsius temperature to its corresponding Kelvin temperature by adding 273 degrees to the Kelvin temperature. Here we have problem 1. The temperature in a hospital is set to 21 degrees Celsius. What is that in Fahrenheit? Step 1, 1.8 times degrees Celsius plus 32. Step 2, 1.8 times 21 plus 32. This gives you 38 plus 32 for a total of 70 degrees Fahrenheit. For my graphic, I depicted a thermometer. On here, it's at the degrees 60 for Celsius. What is this in Fahrenheit? So you do 1.8 times 60 plus 32, which gives you a total of 140 degrees Fahrenheit. Relating concepts with daily life. For a Canadian to come to the USA, they would have to know how to convert Celsius to degrees Fahrenheit, because there they use degrees Celsius. A helpful website for this topic was Converting Temperature by BBC Upgrading on YouTube. I chose this link because it was pretty simple and straight to the point. The link gives you 2 conversions for Celsius to Fahrenheit and Fahrenheit to Celsius. Lastly, it even gives you quick examples to ensure you are converting properly. The only downfall of this link is it did not display how to convert to Kelvin.
Energy is defined as the ability to do work. Energy can be classified as either potential or kinetic. Potential energy is determined by the position of an object or by the chemical composition of a substance. Kinetic energy is the energy of motion. Heat is the energy associated with the motion of particles. An ice cube feels cold because heat flows from your hand into the ice cube. The SI unit for energy and work is the joule. The joule is a small amount of energy, therefore scientists often use the kilojoule, which is 1,000 joules. A calorie means heat and is defined as 4.184 joules. 1 kilocalorie is equal to 1,000 calories. Okay, we have a multiple choice question, and it reads, what is the energy of motion? The energy of motion is kinetic energy. And this relates to real life concepts by a boulder resting at the top of a mountain has potential energy because of where it is located. However, once the boulder rolls down the mountain, the potential energy becomes kinetic energy. Okay, energy and nutrition. The food we eat provides energy to do work in the body. Carbohydrates are primarily the fuel for the body. However, when there are no carbohydrates, fats and proteins are used for energy. The energy values for food are the kilocalorie or kilojoule, obtained from burning 1 gram of carbohydrate, fat, or protein. My interactive website was Energy Kids, and the website's strengths were how thoroughly they described what energy is and the types of energy. It also had many interactive elements such as games and quizzes. The weakness of this website was that it was quite childish, and teenagers or adults may have a hard time fully engaging in the pertinent information because of the juvenile setup.
Each substance has its own characteristic ability to absorb heat. Adding heat to water increases its temperature until it is boiling. Heat storage instruments are very useful, and they are usually made of substances with a high specific heat capacity. Some substances absorb more heat than others to reach a certain temperature. The energy requirements for different substances are described in terms of physical property, defined as the amount of heat needed to raise the temperature of exactly 1 gram of substance by exactly 1 degree. The heat equation is heat equals mass times the temperature change times specific heat. The specific heat equation is heat over grams times temperature change equals calories or joules over grams Celsius. For my multiple choice question, I had how much heat must be absorbed by 375 grams of H2O to raise its temperature by 25 degrees Celsius. First, you have to find the mass, which is given to you. What is given to you? The mass is given, and the temperature change is what's given to you. But you would know from memory what the specific heat of H2O is, which is 4.184 joules of grams Celsius. Then you would plug what you're given into the heat equation, which would be 375 grams times 25 degrees Celsius times 4.184 joules over grams Celsius, which gives you where heat equals 3.9 times 10 to the 4 joules, which is C. A large bottle containing 883 grams of water at 4 degrees Celsius is removed from the refrigerator. How many kilojoules are absorbed to warm the water to room temperature of 22 degrees Celsius? We have to first find out what is given, which is 883 grams of water at 4 degrees Celsius, and you need to find what the kilojoules is at 22 degrees Celsius. You use your heat equation and also your specific heat of water to find out that heat equals, well, first you have to change it to Kelvin, and then you do 0.883 kilograms times 4.2 times 19 degrees Kelvin equals 70.4 kilojoules. For my website, I use Khan Academy, where he does a video demonstration of what specific heat is, and I think one of the strengths of the website was that it was very colorful, and each different topic that he was talking about or step he did was in a different color. But the only downfall is that his voice is very dragging and can be boring at times.
Changes of state consist of melting, freezing, heat of fusion, evaporation, boiling, condensation, sublimation, heat of vaporization, and heating and cooling curves. When heat is added to a solid, the particles move faster at a temperature called the melting point. The particles of a solid gain sufficient energy to overcome the attractive forces that hold them together. When the substance is melting, it changes from a solid to a liquid. When kinetic energy is lost, the particles slow down and the attractive forces pull the particles close together. This is when the substance is freezing. A liquid changes to a solid at a freezing point. The heat fusion is the energy that must be exerted to convert exactly 1 gram of a solid to a liquid at the melting point. Evaporation is taking place as water molecules with sufficient energy escape from liquid surface and enter into the gas phase. At the boiling point, the molecules within a liquid have enough energy to overcome the attractive forces and become a gas. In the process called sublimation, the particles on the surface of a solid change directly to a gas with no temperature change without going through the liquid state. The heat of vaporization is the energy that must be added to convert exactly 1 gram of a liquid to gas at the boiling point. On a heating curve or cooling curve, the temperature is shown on the vertical axis and the loss of gas of heat is shown on the horizontal axis. For problem 1, in a sauna, 122 grams of water is converted to steam at 100 degrees Celsius. How many kilojoules of heated I need to stop right there. For my graphic, this is an example of a heating curve. Right here you can see where heat is added, and this just shows it changing from a solid, it's melting, then a liquid, where it's boiling, and then it eventually becomes a gas. For problem 2, identify each of the following changes as melting, freezing, sublimation, or deposition. A. The solid structure of a substance breaks down to a liquid form. This is melting. B. Coffee is freeze-dried. This is sublimation. C. Water on the street turns to ice. That's freezing. Lastly, D. Ice crystals form on a package of frozen corn. Deposition.